Okay, folks, special right triangles. You know, we've been talking about Pythagoras and the right triangle and the Pythagorean theorem and all that good stuff. But you know, there are two very special triangles that we need to talk about, and they have names. And the first one is named the 45-45-90 triangle, and the next right triangle that's special has a name of 30-60-90. Guys, you're going to see these a million times in trig. You'll probably talk about it some in geometry, and in fact, we're going to talk about it a little bit in the next couple of sections. But we need to know these two special triangles. We need to have them memorized. Now, I may have to do two intros here, but I'm going to tell you where they both come from. All right? Let's deal with this first one. I'm going to draw a square. Okay? And I'm going to say that this square, because it's a square, has all the same sides and they equal 1. Okay? Now, if I draw a line cutting this square in half, I'm going to get a triangle. All right? So I'm just going to get rid of this other side. Okay? Now I've got a triangle here. And since it was a square, you guys know that this is a right angle here. Right? But since I cut it in half, this angle is 45 degrees and this angle is 45 degrees. So if I cut the square in half, I get a 45-45-90. All right? So you know that the first one I'm talking about is this one. Okay. But now using Pythagoras, if I do a squared plus b squared is equal to c squared, right? In this case, it'd be 1 squared plus 1 squared is equal to c squared. All right, I need a little more room. I get 1 plus 1 is equal to c squared. 2 equals c squared. I take the square root of both sides and I get c is equal to the square root of 2. Now I don't use the negative because this side can't have a length that's negative. Okay, so we're only using the positive. So if the sides are 1, here let me put this down. 1, 1, and 1 root 2. I always multiply, to get the length of the hypotenuse, I multiply a leg times the square root of 2. All right? 1, 1, 1 root 2. If this were 2, 2 root 2. 3, 3, 3 root 2. 4, 4, 4 root 2. Hey, how about this? Root 2, root 2, root 2 times root 2, which is root 4, which is 2. Interesting. Okay, so let's go back up just for a moment and look at the little diagram I had drawn for us here. X, X, X root 2. You need to memorize it. The legs are the same, right? They're both x's, and the hypotenuse is a leg times root 2. Memorize it. You'll get it. Okay? All right. Now with the 30, 60, 90, you know what? I'm going to draw a triangle, guys, as best I can here that's equilateral and equiangular. Not bad, Mr. C. That's close, I guess. So this is 60 degrees. This is 60 degrees. And this is 60 degrees. Okay? Now, if it's equiangular, like all the angles in the triangle are the same, all the sides have to be same because they open up the same amount. Right? This is going to be 2, this is going to be 2, and this one's going to be 2. Okay? But, you know what I'm going to do? I'm actually going to draw what's called an altitude. I'm just going to cut this triangle in half, right, and make a right angle here, okay, and I'm going to get rid of one of these triangles. Okay, well, messing it up. That's all right. I'll get there. Don't worry about it. All right. There we go. All right. Now, it's no longer, this bottom side's no longer 2. It used to be 2, but once I cut it in half, this thing is now 1. I wonder what this is over here. Big question mark. Well, it's definitely 1 squared plus b squared is equal to c squared. So I'm going to get 1, I'm sorry, not c squared, but 2 squared. I'm going to get 1 plus b squared is equal to 4. I'm going to subtract 1 from both sides and get b squared is equal to 3. I'm going to take the square root of both sides and get that b is equal to root 3. Root 3. Now guys, I'm going to stop because I'm running out of time, but we'll do another intro, so look for it.